We call this simplifying by combining like terms, and now the connection is that we are going to do the same thing with radicals. That in order to add radicals together, and this is partially why we did that activity at the beginning, you can only add radicals together if they belong to the same family. So in this example right here, this root 3 and this 4 root 3 can be added together to make 5 root 3s. But you can't combine it with the 2 root 7s. So when we go to example 1, we can write out the strategy. First, in order to find out what family something belongs to, we have to change everything to mixed radicals. And then we'll be able to add the ones that are alike. So part A, can you see that step 1 is already done for us? We have 9 root 5 minus 5 root 5. They are already like radicals. They're already written as mixed radicals. And so if you have 9 of something and you subtract 5 of something, you're left with 4 of something. So in part A, this is just a matter of saying that that's equal to 4 root 5. Part B, they are not like radicals currently. We need to figure out what family they belong to. So I'm going to rewrite part B here. So we started with the cube root of 24 minus the cube root of 192 minus the cube root of 375. And what we do to write it as a mixed radical, and I'm just going to get it set up, is we break up each of these numbers. So we're going to break up 24. And the first one that you're going to write has to belong to your powers charts for cubes. So you have to think of your powers of 3. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. And you have to find what's the biggest one that divides 24. Fill in those numbers. Okay, I'm going to give you 30 seconds to fill those numbers in on your own. I'm going to write out the first 5 cubes. So in order to write something as a mixed radical, we have to know, in this case, what our cubes are, and then be able to break down these numbers. Can you see that 24 is divisible by 8? So we would write 8 and 3. 192, a little bit tougher. So we would start, well, not 216, not 125. We try 64. You might even have a calculator, so you'd be like, okay, I'll try 64. And sure enough, it's 64 times 3. Same thing with 375. 216 doesn't work, but 125 does. Now we take this extra step to write it out this way, and then the ones that are perfect cubes, you can simplify. So cube root of 8 is 2, so we would be left with 2 cube roots of 2. 64 cube root is 4. And 125 cube rooted is 5. So we were successful in changing them from entire radicals to mixed radicals. So now that we have all of these are like radicals, they're all cube roots of 3. You have 2 of them, minus 4 of them, minus 5 of them. In the end, that would end up with minus 7 of them. And then for part C, we've got square root of 63 minus the square root of 40 minus the square root of 90 minus the square root of 28. So now these are square roots. So now you're looking for your perfect squares. So I'll get the setup. You've got to find the biggest perfect square that divides each of those. All right. You find out 9 was the biggest one that here, 9 and 7, because 9 is 3 squared. 4 and 10, because 4 is 2 squared. 9 and 10, because 9 is 3 squared. And 4 and 7. Then the square root of 9 is 3, so this is 3 root 7s minus 2 root 10s minus 3 root 10s minus 2 root 7s. Do you have to show this step? No. But I would ask you, if you don't show that step, that you do a quick mental math check to make sure that what you wrote here, right? 3 root 7, well, is that 9 times 7, 63? Yes. Do a quick check, because what I see sometimes happening is I see sometimes people write 9 root 10 instead of 3 root 10. So you can skip that extra step. I'm showing it right now so we see where the numbers come from. But always, when you do your mental math, always double check it when you're done. Now, do we have some like terms? Yes. 3 root 7s minus 1 root 7, or 2 root 7s will leave you with 1 root 7, and minus 2 root 10s minus 3 root 10s, that'll leave you with minus 5 root 10s. And we cannot put the root 7 and the root 10 together because they are not part of the same family. So, try some on your own. 3, 4, 9,